Hi, this is Kate, and we're solving inequalities. Consider a balanced scale. As long as it has the same weight on each side, the scale is in balance, and we can use it to model an equation. But if one side is heavier, the scale is out of balance. We can no longer say the two sides are equal, but we can say one side is greater than or less than the other. This is called an inequality. There are 6 green squares on the right side of this balance. There are 2 green squares and an unknown value on the left side. Which statement must be true about the value of the blue bar? The blue bar must be worth more than 4 green squares. Since the left side is heavier, we can say the left side is greater than the right side. To simplify things, we can remove 2 green squares from each side. The sides will keep the same relative value. And then it's easy to see that the blue bar must be worth more than 4 green squares. Solving inequalities is very similar to solving equations. Can you figure out which value of x could we plug in and make this inequality true? The only value that would make it true is 3. To summarize all the values that would make this inequality true, we can solve it much like an equation. We can get the x's together by taking away 2 x's from both sides. We can subtract 1 from both sides, and then divide both sides by 3. 4 is greater than or equal to all the values that make this true. The only value that 4 was bigger than of the choices was the 3. Please solve this inequality just as you would an equation and make the best selection. If you followed the steps to solve an equation, you should have determined that the solutions are all the values that are less than 4. You would get that if you subtracted 12 from both sides and then divided both sides by -2. So the solution should be all the values that are less than 4. But if we check some values, something fishy is going on here. What happens if we pick a value that's less than 4 and substitute it in? Is this inequality true when x is 0? When we substitute in a 0, -2 times 0 is just 0. 0 plus 12 is 12. And we get a statement that says 12 is less than 4. This is not true. So what in the world's going on here? We didn't make any mistakes while we were solving it like an equation. There must be something we haven't thought of. To investigate this, we'll compare 6 pairs of numbers. For now, we're just comparing a 4 and a 1. So in all of these cases, 4 is greater than 1. However, we're going to do some things to both sides of these inequalities that might change what symbol goes in the middle. If we multiply both sides by 3, now we're comparing 3 times 4 is 12 to 1 times 3 is 3. Okay, the left side is still greater than the right side. What about if we multiply both sides by 2? Which symbol is appropriate? The left side is still greater than the right side because 4 times 2 is 8 and 1 times 2 is 2. Now we'll multiply both sides by 1. We get a 4 and a 1. The left side is still greater. What happens if we multiply both sides by 0? Which symbol is appropriate? Well, 4 times 0 is 0, and so is 1 times 0. These two sides come out to be equal to each other. That's interesting. Okay, continuing the pattern, 3, 2, 1, 0. Next we'll multiply both sides by -1. Which sign is appropriate after we multiply both sides by -1? -1 times 4 is -4. -1 times 1 is -1. -4 is less than -1. When we multiplied both sides by a positive number, the left side remained greater than the right side. But when we multiply both sides by a negative number, it flips. Now the left side is less than the right side. If we multiply both sides by -2, -8 is less than -2. The moral of the story is that solving inequalities is almost the same as solving equations. The only difference is, if you ever multiply or divide both sides by a negative number, you need to flip that inequality over. So let's see how we should have solved this inequality. We're going to treat it just like an equation except for that one exception. I'm going to subtract 12 from both sides. Okay, just the same there. But now when I divide both sides by a -2, I need to change the less than to a greater than. The solution to this inequality is all the numbers that are bigger than 4. This is Kate, and you've been solving inequalities.